All right, so today we're going to be discussing linear quadratic equations and solving them, their solutions, what happens when we solve them. Okay, so first things first, we kind of have three different types of solutions we can get when we have these, or three types of scenarios we can have for this sort of problem. When we're looking at these three, it's kind of best to look at them visually. So I'm going to kind of draw them out and we can discuss from there. So the first type we have, I'm going to just call it type 1. Type 1 is when we have a parabola, and then we have a line that goes through the parabola, and it intersects the parabola at 2 points. So we'd say for type 1, we have 2 intersection points. All right. Then if we move on to type 2, we have our parabola, but this time our line intersects the parabola at 1 point, at our vertex. So we would say we only have 1 intersection point. And then for our last type, I'm going to call it type 3. This is when we have the parabola, but our line does not intersect our parabola at all. So we would say that we have 0 or none, or no intersection points. Okay, so now that we've gone over the different types, I guess we can move on to solving some of these problems and what these problems might look like. So I'm just going to scroll up. So for our first example, I'm going to call it example 1. We would say find the intersection points. I'm going to put the S in brackets just because we don't know if it's going to be 1 or 2 yet. And then I'm going to give us some equations. Y equals 5x plus 6. We have y equals x squared plus 4x plus 3. Okay, so what we're going to want to do with these is we want to find where these two equations intersect, right? And in order to figure that out, we're going to have to set them equal to each other, right? We want to find where are the point or points where these two graphs have the same value. The only way we can determine that is by setting them equal to each other, because then it will reveal the common value these graphs have. So what I'm going to do is I'm going to say 5x plus 6 is equal to x squared plus 4x plus 3. So again, I set these equal to each other. Now that I have this, I want to put this into a form where I can solve for the value of x, or the values of x, that will result in an intersection point on our graph. So in order to solve for value or values of x, I'm going to bring everything to one side so that I can have my equation equal to 0. So I'm going to say 0 equals x squared plus 4x plus 3. And then again, I'm bringing this over to this side. So I'm going to subtract 5x plus 6. I'm going to say minus 5x minus 6. Okay, so now that I have this, I can kind of collect my like terms and clean up this equation a bit. So I get 0 equals x squared, and then I have my two like terms. I have our 4x and negative 5x. So I would say x squared minus x, and then I have 3 minus 6. So then I would say minus 3. So I have in my next line of my equation, I have 0 equals x squared. 0 equals x squared minus x minus 3. Now, back in grade 10 math, if we think about what we did back then, we can remember that we saw this type of equation before. And this is just regular, trinomial. We can factor this. So we say if we want to factor this, we want something that is going to multiply to negative 3, but add to negative 1. So what comes to mind for that is x minus 3, and then we write x plus 2. So we would say that if we take this value from in here, we get x is equal to 3, x is equal to negative 2. So we know that when x is equal to negative 2, we have an intersection point, and when x is equal to 3, we have an intersection point. So this is telling us we have 2 intersection points. And this is telling us basically it's like a type 1 problem that we mentioned earlier on, right? Okay, so now that we have this, we can substitute these x values back into either of the equations at the top here. We can substitute it into this one or this one. It doesn't matter which one. We'll get the same points either way. I'm going to go with the y equals 5x plus 6, the linear one, just because it's simpler, less terms to deal with. But again, you get the same result either way. So I'm going to say y is equal to 5, and I'm going to substitute in x equals 3. So we have 3 plus 6. 5 times 3 is 15 plus 6. That's 21. So that we have one solution at 3, 21. And then I'm going to substitute my other x value in. So I say y is equal to 5. And then we're using negative 2 plus 6. 5 times negative 2, that's negative 10 plus 6. Negative 10 plus 6 is negative 4. So we have another solution at negative 2, negative 4. So we can say, therefore, the solutions are 3, 21, and negative 2, negative 4. And that's how we would solve this type of problem. Okay, so if we're all good with this, we can move on to another example problem that we might see for this kind of, this chapter or this lesson. I'm just going to move some stuff up, and it's going to be example number 2. And in this, we're going to say determine the value of k if the line y equals 7x plus 3 intersects, oops, running out of room, the parabola, and then we're given another equation, which is y equals negative 2x squared plus 13x plus k at only 1 point. Okay, so just like the other problem, we're going to want to start off by setting the two equations we have equal to each other. Okay, so let's do that. So we're going to say 7x plus 3 equals negative 2x squared plus 13x plus k. All right, so again, we're going to move everything to one side so we can set this equal to 0, just like we did before. 0 equals negative 2x squared, and then we're going to say plus 13x plus k, and then I'm going to say minus 7x minus 3. Okay, just like before, we're going to collect our like terms. So we say 0 equals negative 2x squared, and then we have 13x and negative 7x. So if we collect those, we get we're going to get 6x, my bad, sorry, plus 6x, that took a second, it shouldn't have, and then we have plus k minus 3. So now that we have this, what we want to do is we want to assess what all of our values were if we were to use the discriminant for this. If you're not familiar with the discriminant, basically, in order to have one point of intersection of a parabola with the x-axis, we need this equation b squared minus 4ac to equal 0. And if this equals 0, then we only have one intersection point on our parabola with our x-axis. So because we've kind of put this into a form of it just being a parabola on our x-axis, when we solve this, it will tell us where our one intersection point is with our equation of a line. So if we look at this, we can say that, okay, our b value or our a value is negative 2, our b value is 6, And our C value is k minus 3, right? We have C, B, and well, maybe you should underline the whole thing. This is C, this is B, and this is A. So if we were to put this into our discriminant form here, we would say we have 6 squared minus 4 times negative 2 times k minus 3. And we want this to be equal to 0, right? So we're going to find the value of k that'll make this equation true. So what we do now, 6 squared, that's 36. And then minus 4 times minus 2, that's going to be 8. So we'll say plus 8, and then we have k minus 3 equals 0. I'm going to expand this using our distributive property. So we get 36 plus 8k, and then minus 24 equals 0. All right, so what I'm going to do is we say 36 minus 24, that's 12. So we have 8k. That's going to be, so we'll have 12 left. Sorry, not minus 12. It's going to be 12 left. So plus 12 equals 0. We're going to bring the 12 over to the other side so we can solve for k. When we do that, we get negative 12. And then we're just going to bring a little arrow because we're running out of room down there. So we have 8k equals minus 12. And then if we divide that out, divide both sides by 8, we get negative 3 over 2. So that would be our final answer for this. So we would say, write a little concluding statement, say therefore, if k equals negative 3 over 2, y equals 7x plus 3, and y equals negative 2x squared plus 13x plus k will, let's scroll down, sorry, intersect at only one point. Yeah, so that's how we would solve this problem. Okay, so that concludes our lesson for linear quadratic equations. Good night.